Very good morning. In today's video lecture, we will discuss regarding the modes of different modes of operation in magnetron oscillator. Okay. As in case of reflex klystron also, we had seen the different modes of operation, in which mode we can able to operate the reflex klystron. Similarly, we will see some of the modes that is being commonly utilized in the magnetron oscillator also. Okay, as you know, the magnetron oscillator, it consists of a cylindrical cathode surrounded by anode cavities. Okay, that is already we have seen in the figure what we had discussed in the previous video lecture. So I will write that 2 points here. That is consists of magnetron oscillator consists of what? A cylindrical cathode surrounded by the anode with the cavities. Anode with the cavity. These are the things what we have discussed previously, or we have seen from the picture representation of a magnetron oscillator. Similarly, it consists of a permanent magnet that provides an external magnetic field, with flex lines, magnetic flex lines parallel to the axis, axis of the cathode, parallel to the axis of the cathode. Okay, one more point I will write. The output power is taken from one of the cavities by the means of coupling loop. Output power is taken from one of the cavity, cavities by means of coupling loop. Okay. So one more thing, anode is made up of copper. Okay, that also keep in mind. Anode is made of copper regardless of its shape. Anyway, anode is made up of copper. Okay, I will write that out, regardless of its shape, regardless of its actual shape. Okay. So in today's video lecture, I will explain the resonant modes and the separation. Similarly, some of the modes of what you called as cavity magnetron oscillator. So the cavity magnetron, it has number of resonant cavities that already we have seen. Hence, there must be it must have an equal number of resonant frequency, or we can call this as mode of oscillation. Okay. So normally we are operating the pi modes. Normally the magnetron oscillators are operating in pi modes. Okay. So before coming to that one, I will explain what are the things what I am going to explain in this today's video lecture. That is, I will give you a brief idea regarding the zero mode in magnetron. Okay, zero mode in magnetron. Second point, I write as a pi mode. I write like that, pi mode in magnetron. Third point, mode jumping. Mode jumping in magnetron. Okay, and the last point is, in order to avoid the mode jumping, we should have strapping. Strapping in magnetron. Strapping in the sense means to avoid mode jumping. To avoid mode jumping, we are normally utilizing the strapping. So one by one we can see the different modes as well as the mode jumping, and how to overcome that mode jumping in cylindrical magnetron oscillator. So let me see the first case, or I will give you the first point, that is the resonant modes and the separation. After that I will come to the zero mode in magnetron. Resonant mode, RSONANT, modes and the separation. Resonant modes and the separation. So I will give you some point. The first point is the cavity magnetron. As I told you, the cavity magnetron has a number of resonant cavity. Has a number of resonant cavities. And hence must have an equal number of what? Resonant frequency. Or we call this as modes. Okay, equal number of resonant frequency or modes of oscillation. Clear? So oscillations. Okay, so normally the second point, normally pi mode. I will explain before coming to the pi mode. Pi mode is normally used for magnetron operation. Pi mode is normally used for magnetron operation, where in the phase difference between the adjacent anode pole is pi radian. That already we had discussed in the while we are giving the structure of the magnetron oscillator. Okay, pi mode is normally used for magnetron operation, wherein the phase difference, one minute, between adjacent anode pole is pi radian. Okay, for all modes, I write for all modes, the condition that also we have discussed, the condition is that the total phase shift around the cavities should be a multiple of 2 pi, should be a multiple of 2 pi radian. Okay. Third point, hence what we had drawn is 8 cavity magnetron. Hence for 8 cavity magnetron, what we have seen in the previous video lecture, we can have what? Pi mode, because normally it is being operated in the pi mode, comma 3 pi by 4 mode, comma pi by 2 mode, comma and pi by 4 mode. Okay, these are the things I want to explain to you. Now coming to the what you called as mode separation and all those things, I will explain in the general case. So before that, because in case of mode separation, each mode of each mode of operation of your magnetron will be corresponding to a different frequency. Okay, so I will show that with the while we are explaining the mode jumping. Okay, I explain that point while we explain the mode jumping. So now first of all, I will come to the 0 mode and pi mode in a magnetron oscillator. 1 minute, I had drawn one figure here. Let me bring this figure into down. Because I have to write certain points here. Okay, let me bring this figure in somewhere down. Okay, now it's okay. So I will first of all explain with the 0 mode. 0 mode in magnetron. The first point is zero mode in magnetron. Okay, how we can represent modes in magnetron? Can you know what are the different, how we can able to represent the modes in a magnetron oscillator? So I will write that one. 1 minute. That is the first point. If, because the representation of modes, okay, if phi represent the relative phase, if phi represent the relative phase change of the AC electric field, across adjacent cavity, then I can write phi equal to 2 pi n by capital N, where n equal to 0, plus or minus 1, plus or minus 2, etc., 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 plus or minus n by 2. It means that there could be what? N by 2 number of modes. There could be n by 2 number of modes of resonance can exist if capital N is an even number. That is, it means that there could be n by 2 number of modes of resonance. There could be n by 2 number of modes of resonance can exist if n is an even number. Capital N is an even number. So there could be a total n by 2 number of modes which is possible. I will write that. So there is, or there is total n by 2 number of modes which are possible. Okay. So if I consider a value for n equal to 0, then if I consider a value for small n equal to 0, then you can write phi equal to 2 pi into 0 by n, which is generally is nothing but 0, which implies phi equal to 0. Okay. So if phi is 0, then there is 0, this is nothing but operating in 0 mode of magnetron. Okay. If phase is 0, that is phi, phase is 0, this is 0 mode of magnetron. Keep in mind, this is 0 mode of magnetron. Okay. So if I put small n equal to capital N by 2, then phi equal to 2 pi capital N by 2 divided by n. So this 2 and 2, this 2 and 2 can cancel, this n and n can cancel, ultimately it will be pi, that is phase phi equal to pi. This is pi mode of magnetron. This is pi mode of magnetron. Okay. This is how we can have 0 mode and pi mode, okay, of magnetron by substituting the values of n equal to 0 and n equal to n by 2, and based on the phase we can now justify what mode, or we can now justify the 0 mode as well as the pi mode. Okay, justification for that is justification by substituting the values of n equal to 0 and n equal to n by 2, and based on the phase what we have obtained, we can justify the 0 mode as well as the pi mode. That is justification of 0 mode. What is the justification? 0 mode is not useful mode in magnetron oscillator. I will tell you the reason. It is not useful mode in magnetron. The reason where you will be finding is that because there is a energy is happening in anode cavity with a 0 phase difference. That is, the reason is energy is happening in anode cavity. Energy is happening in anode cavity with 0 phase difference. So there will be no generation of signal. So there will be no generation of, with the 0 phase difference, anode cavity with the 0 phase difference, there will be no generation, but what I told you, there will be no generation of signal because of 0 phase, as electric field is not having any phase, as electric field is not having any phase. Okay. This is the point what I had to explain for the zero mode in a magnetron oscillator. Okay. So, I will bring again this figure down. One minute. Because we have to write more things regarding this one. So, let me bring down somewhere here. Okay. So, I think it is clear for you. So, there will be no generation of signal because of zero phase, as electric field is not having any phase. That is the justification of zero mode. Let me now justify how the pi mode is efficient. Pi mode, justification of pi mode, and how it is efficient. Okay. In the in this, what happens, the adjacent cavity will have 180-degree phase difference, that is phi equal to pi, which is nothing but 180 degree, that we have seen. In this, adjacent anode cavity have 180-degree phase difference, so phi equal to pi, which is equal to 180 degree. Okay, that's the thing what we have obtained when putting the values of n equal to capital N by 2. So pi mode is most commonly used mode in magnetron oscillator. That also is pi mode is most commonly used modes in magnetron. Okay, and that is because of it, if we are operating in pi mode, we will have maximum efficiency of operation at a phase difference of 180 degree. That is, there will be maximum efficiency of operation at phase difference of 180 degree. Since the anode cavity has a phase difference of a phase difference of 180 degree. Since the anode cavity has a phase difference of 180 degree, that is, one plate is positive in the sense means other plate is negative. That is, one plate is this, and all this I had explained in the working here. One plate is positive, then next plate is negative, and all anode adjacent cavities operated by 180 degree phase difference. All anode mode jumping in magnetron. Mode jumping in magnetron. So magnetron, when it is being operated under pi mode, it gives maximum, that is most commonly mode is nothing but the pi mode. It gives maximum output power and at a desired frequency. Okay. Since the magnetron has 8 coupling cavity resonator, several different modes of oscillation is possible. Okay. Several several different modes of oscillation is possible. So the oscillator frequency corresponding to the different modes are quite close to each other, very close to each other sometimes. So that a pi mode oscillator, which is normal for a magnetron, sometimes there will be a switching of one mode to the other mode. Because of switching of one mode to the other mode, magnetron goes in jumping from one mode to other mode, called as mode jumping. Okay. From one mode to other mode, frequency corresponding to mode is very nearer, very nearer. Okay. So to avoid this, there we use strapping. Okay. So mode jumping has to be avoided. Mode jumping has to be avoided. If the mode jumping is there, then we cannot predict in which mode the magnetron will be operated. So in order to avoid the mode jumping, then we have to utilize strapping. Okay, that is, each mode of the magnetron will be corresponding to different frequency. Each mode of the magnetron will be corresponding to different frequency. Okay, so I will just explain that one. That is the first case. Magnetron, in case of mode jumping, magnetron when operated under pi mode is nothing but most commonly used mode, it gives maximum output power and at a desired frequency, Okay. Next point, since magnetron has, in this case I had drawn 8 coupling cavity resonator. Sometimes it can be 12, sometimes it can be 20 and all those things. Don't bother about 8 coupling cavity resonator. Several different several different modes of oscillation is possible. Modes of oscillation is possible. Okay. So next point I will write, the oscillation frequency corresponding to the different modes, frequency corresponding to different modes, they will be very close to each other. Okay. Different modes are quite close to one another. Okay. So that a pi mode oscillation which is normal for magnetron, red bracket, sometimes there will be switching. Okay. Sometimes switching of one mode sometimes switching of one mode to other mode, other modes. Sometimes there will be switching of one mode to other mode because of switching of one mode to other mode. Because of switching of one mode to other mode, the magnetron goes in jumping. Magnetron goes in jumping from one mode to other mode, from one mode to other mode. Okay, jumping from one mode to other mode. For corresponding mode, that is magnetron goes in jumping from one mode to other mode, and the frequency corresponding to mode to the jumped mode is very nearer by, very nearer by. Okay, so to avoid this, we use strapping. To avoid this, we use strapping. I will explain the strapping also. So that is, in order to avoid the mode jumping, strapping is used. That is, to avoid or in order to, I will write that one, in order to avoid the mode jumping, to avoid the mode jumping, what strapping is used. Strapping is used. Okay. So if they are asking something regarding the mode separation, I will give you some small point here. Mode separation, same thing only. That is, each mode of operation of the magnetron corresponds to a different frequency Okay, I will show a relation between the frequency of different mode for the strapped and unstrapped cases. Okay, so I will draw here. Somewhere 0, 2, 4, 6, 8, 10, 12, 14. These are wavelength, lambda in centimeter. Okay, and this is nothing but modes. This is pi by 4, pi by 2, 3 pi by 4 and pi. Okay, so just draw like this. On the point, just I will put it in the dotted lines. You also just draw this one. Okay, okay, somewhere from 8 to here, 8 to 8 itself, like that. It is called unstrapped case. Unstrapped case. From here, from 2 point something to, I will call this as from like this only, it will go to somewhere here. Okay, this point, and this point is very important. Okay, this is called strapped case. So this strapping has to be avoided. So this is nothing but a free a graph which shows the relationship between the frequency of different modes for both strapped and unstrapped case. For both strapped and unstrapped case. Okay, so the pi mode differs very little in wavelength from the other modes for the unstrapped case. You can see that from the figure. Okay, this just the figure that what I had drawn here. The pi mode that will be differs very little in wavelength from other modes for the unstrapped case. In practice, separation of pi mode from other mode will be quite difficult. That is nothing but the mode jumping, that is case, that is nothing but mode jumping. So may occur, which is an undesirable conditions. Okay, so that also I write here. The pi mode is different. Pi mode differs, I write like differs very little in wavelength. Very little in wavelength. Okay, very little in wavelength from the other modes for the unstrapped case. For the unstrapped case. In practice, separation of pi mode from other mode will be quite difficult. Okay. One minute. I'll just bring this again, this figure down. As I told you, the pi mode differs very little in wavelength from the other modes for the unstrapped case. In practice, the separation of pi mode from the other mode will be quite difficult. So, mode jumping occurs in which is undesirable. Okay. So, mode jumping, I will write that one, mode jumping in capital letter only. Mode jumping may occur which is undesirable. So, this has to be avoided. This mode jumping has to be avoided. So, in order to avoid the mode jumping, we normally utilize the method called as strapping. So, a method now commonly used to prevent the mode jumping is called strapping. Okay, I'll write that one. A method commonly used to prevent mode jumping is called strapping. Okay, STRAPPING is called strapping. So strapping mainly consists of two rings of heavy gauge wire that is connecting alternate anode poles, which are like poles. I will show you that one, how we are connecting that one. So one ring is connected to even numbered pole and other ring is connected to the odd poles. Okay, so I will just take that figure from here, what I already had drawn. So I'll just copy this figure. Okay, I'll just bring this figure upper. Okay, I will just paste here. Okay, so here, as you know, this is nothing but what you call as Magnetron oscillator with 8 cavities, because you have in the cavity number 1, cavity number 2, 3, 4, 5, 6, 7 and 8. Okay, so what I will do is I will just place a 2 ring here. One I will draw with a red. Okay, so 2 ring I am be connecting like this. This is the first ring what I am connecting here. Keep in mind. Okay, the second ring I will draw with some other violet color. That is good. I will draw like this. Okay, okay, so from here I will just solder that one. How I am soldering is very important. For red I will do like that. So for red, first I will solder here, next I will solder here, next I will solder here, next I will solder here. Okay, so violet ring I will solder first here, second here, third here, fourth like this. Okay, so if this is positive, this is negative, this is positive, this will be negative, this is positive, this is negative, and this is positive, this will be negative, like that. So these two, the things what I have shown here, these two are heavy gauged rings. Okay, and this positive and negative I call this polarities for pi mode. Okay, one minute, what happened for pi mode. Okay, and this connection and this connection I called as points of connection of rings to anode poles. to anode poles. Okay, I think now it is clear for you. This is the figure for a strapping of cavity, magnetron. So in order to avoid mode jumping, we use strapping, so that strapping is nothing but it is nothing but a two circular ring that is connected to the anode poles. Okay, so I will continue with this one. So already I have wire I have stopped. A method commonly used to prevent mode jumping is called as strapping. Okay, so I will write with that one. Not able to select that one. Anyway, I will do with the what happened. Okay, the next point what I had to take is strapping consists of two rings of heavy gauge wire. Connecting alternate anode poles. In general we can call poles. Okay, anode poles which are like pole as shown in figure, above figure. Okay, consists of heavy gauge wire connecting alternate anode poles which are like poles as shown in figure. Okay, 1 minute. So what we have done here, these are the poles, right? These are the poles that should be in phase with each other for pi mode. Okay, so the phase other than the pi mode should be rejected. Phase other than pi mode is rejected. That should happen in mode jumping. That should happen while we introduce the strapping in magnetron oscillator. Okay, so I will just give you one ring is connected to, as we shown in the figure, one ring is connected to even numbered pole and the other to odd poles. Okay, keep in mind that one. Next point, for pi mode, the two rings should have opposite potential as we are indicated in the figure. Okay, we have indicated in the figure we have opposite potential. The two rings have opposite, one is positive, other is negative. Okay, that is for the pi mode. For pi mode, the two rings have opposite potential as indicated in figure. Okay, next what I will write, the capacitance between the right, the capacitance between rings that will lowers the frequency for pi mode. So a capacitance will be acting between the two rings, and that capacitance will lower the frequency of for the pi mode. Okay. For other mode, for other modes, because of inductive shunt, because it acts ring act as a inductor, in between that one it acts as a capacitor. Because of inductive shunt, the frequency is more. For other modes, because of inductive shunt, the frequency is more. Okay, thus the strapping method increases the frequency, separation between the pi mode and the other adjacent mode modes. I think that is clear. So this separation in frequency and hence wavelength prevents the mode jumping. This separation in frequency and hence wavelength prevents mode jumping. And wavelength prevents mode jumping. I think this is clear for you. Everything I have written here. In case of what are the modes of magnetron oscillator, the mode jumping occurring in magnetron oscillator, and how we can prevent the mode jumping in magnetron oscillator using the strapping method. And thank you. You can see in other next video lecture, we can see the operating principle of what you called as magnetron